This is a 4th generation LED module. The easiest way to identify this is by checking for the gray potentiometers. These can be used to manually adjust the red, green, and blue voltages. For power, there are two 6-pin Molex connectors. This type is considered high power. The low power modules only have a single pigtail. For data, the module chains together with these input and output ribbon connections. Here's what the front of the card looks like. This is a 5th generation LED module. As you can see, the gray potentiometers have been removed. Color adjustment for this generation moving forward are done through the software dynamically. It also uses ribbon cables for data in and data out. All Gen 5 modules are low power, so there's just a single 6-pin power cable. The front of the module looks exactly the same. This is a Generation 6 module. With this newer model, the data connectors have been changed out from ribbon cables to SATA cables. The secondary power supplies are also built onto the back of the module, so there is no need for a secondary power supply. Again, the front of the module looks pretty much the same.
Here we have our two LED power supplies. This is a low power supply. You can tell by the orientation of the 6-pin Molex connectors, where these are all in a row. These are all spread out all over the board. The one thing you want to know about power supplies is there will be a tag on each one. It'll tell you the voltages for each color, so red, green, and blue, as well as the 5-volt power.
This is a primary power supply. There are usually 7 of these in a standard billboard sign. We call it a donga, which is actually the name of the manufacturer. It'll accept anywhere from 100 to 240 volts and outputs at 27 volts DC. Newer models output at 24 volts, but they're still interchangeable. On the top of the donga, we have a power button as well as some diagnostic lights. The ones worth mentioning are the on light, STB for standby, and the fail light. On the bottom end, we have the connection for the fuse card. This is what we call a fuse card. It's basically used for power distribution. The bigger terminal is for incoming power. This typically will be 240 volts AC. The smaller terminals are for output at 24 volts DC to the modules or secondary power supplies. Each output circuit is protected by a 10 amp fuse and has an indicator light to tell you if the fuse is good. The RJ45 ports are used for serial communications. We also have dip switches that are used to give each power supply a unique ID and diagnostics. This connection on the end is what plugs into the transformer or donga.
We have here the Wi-Fi interface. We have the DVI input, the DVI output. This is what we call the EDID chip. This is our link light that indicates connection to the PC through the DVI port. This is our power connection over here, and this is our row of LEDs that give us error lights as well as our frame and header light. This is also called the bank light that is an indicator of the board is working properly. These are our ribbon cable connections. There's 8 of them on this board, and then there's the dip switches as well as the EEPROM. This is a Y6 interface card. The differences between a Y6 and a Y5 is we have SATA cable connections instead of ribbon cables, and there is no EDID on the board itself. Still have power, EEPROM, dip switches, the DVI and the DVI output, as well as the LED indicator lights for frame and header and errors. And these are our 2 serial connections for incoming and outgoing. This is the Y7 interface. The biggest difference between the Y7 and the Y6 is that we have 16 SATA ports instead of 8. We still have power connection, dip switches, the EEPROM is covered and non-replaceable, as well as the DVI in and DVI output, and the LED lights, indicator lights are right there. And we still have the serial connections. This is the iBase PC. You'll find this in the remote enclosure. We have our DB9 to RJ5 connectors. This is for our serial communication to the interfaces, the dongas, as well as the light sensor. And then on the front side we have our USB connections, our network connection, and our DVI output. This is the Aries PC. It's very similar to the iBase. The biggest difference is you'll use USB connections instead of DB9 connections for your serial connection. This one also has a VGA output instead of an HDMI. Same thing with network connections, your power connection here, and your DVI out. This is the Portwell PC that you'll also find in the remote enclosures. As you can see, power connection here. This is the power button or reset button. VGA, DVI, HDMI output, your USB cables connections, and your network connections. And this is the top view of the Portwell. This is a Meanwell power supply. We use this to power the PCs in the remote enclosure. It has a standard 3-prong plug with 120 volts coming in, then 12 volts going out to the PC. You'll want to check the DCOK light to make sure it's working properly.
This is what we call a USB 422 adapter. It allows the internal computer to communicate with serial devices over Cat5. In the computer cabinet, you'll normally see 3 of these sitting right next to each other. One typically controls the interfaces, another communicates with the power supplies, and the third is for the light sensor. The USB connection goes into the computer, and the RJ45 cable connects to the serial device. There's an RX and a TX light on the back of the circuit board to indicate if there's bidirectional traffic.
This is the light sensor we use for outdoor displays. You'll want to mount this facing north-south to make sure we get good light on both sides, as well as a temperature sensor that you'll want to either put inside the cabinet or just underneath it. And it has a standard RJ45 connection that will plug into the power connector in the remote enclosure. This is the Mobotics camera. This is the one we use now currently for all outdoor displays. It's pretty straightforward. Just have the lens cap. Lens is inside there. The mounting is on the back, so you have 4 screws, and then you have your network cable going into the remote enclosure.